Problem 4. An aluminium wire 10 millimeter long is 10 meter long is cooled from 38 degrees centigrade to minus 1 degree centigrade. How much change in length will it experience? So, for change in length as a result of change in temperature, we can use this equation. So this equation is delta L, change in length, is equal to L naught, which is the original length. L is the coefficient of thermal expansion times change in temperature. So change in temperature is the final temperature minus the initial temperature. So in this case, if I take delta L, what we need to find is delta L is equal to original length 10 meter multiplied by alpha L, which is given as alpha L for aluminium is given as 23.6 into 10 to the power minus 6 per degree centigrade, and temperature changes. Final temperature is 38 degrees centigrade. 30 is cooled from 38 to minus 1. Okay, so minus 1 is the final temperature and cooled from 38. Okay, so it is 39. So 10 times 39 times 23.6. So this value will be, so this will be equal to minus 0.009204. So meter. So which means that it will be 9.2 millimeter. The minus sign shows that the length will decrease because the temperature was decreased from 38 to minus degree centigrade. So there will be a contraction. Okay. Problem 5. Compute the density for nickel at 500 degrees centigrade. Given that its room temperature density is 8.902 gram per cubic centimeter, assume that the volume coefficient for thermal expansion is alpha V is equal to 3 times alpha L. So in this case, volume change has been given. The formula for the volume change per unit volume has been given, and but the density has been given. So we know the volume density relationship as volume for a given mass. Okay, volume is equal to mass over density. So if you represent volume by V, mass by M, and density by rho, so then V is equal to M rho. So if the initial volume is V1 and the initial density is rho1, so V1 is equal to M1 rho1. And similarly, if the volume is changed to V2, then if the volume is changed to V2, then it will be a new density. Okay, so the change in volume will be equal to V2. For example, if the temperature is increased from a room temperature to 500 degrees centigrade, the volume will increase. So the volume change we can represent as V2 minus V1 divided by V1. Volume change is V2 minus V1, and then if you change its take its ratio by its original volume, so then V2 minus V1 over V1. So it will be M over rho 1 plus M over rho 2 minus M over rho 1, and then divided by M over rho 1. So the equation will be 1 over rho 2 minus 1 over rho 1 divided by 1 over rho 1. Or if you just want to further simplify, it will be rho 1 over rho 2, okay, minus 1. Okay, so that means it is change in volume divided by the original volume. Okay, so in this case I have said original volume is V1, so it's same. So in this case, well, this equation then I can represent as like this: rho 1 over rho 2 minus 1 is equal to alpha V, coefficient of volumetric expansion, which is equal to 3 times the coefficient of linear expansion. So anyway, 3 times alpha L times delta T. So rho 1 is 8.902 at room temperature, and rho 2 we need to find. Minus 1 is equal to 3 times alpha L. Alpha L is given as 13.3 into 10 to the power minus 6. And then delta T is the final temperature minus the initial temperature. Final temperature is 500 degrees centigrade, and the room temperature is normally not given, but we can take it as 20 degrees centigrade. So from here we can solve it for rho 2. So once I will use the calculator and solve it, the value will be 8.735 grams per cubic centimeter. Temperature: must a cylindrical rod of tungsten 10 millimeter in diameter and a plate of 316 stainless steel having a circular hole of 9.988 millimeter in diameter have to be heated for the rod to just fit into the hole. So in this case, you have a steel plate. Okay, maybe this is the plate. In that plate there is a hole, this steel. The hole has a diameter of 9.988 millimeter diameter, and then there is a rod, tungsten rod, okay, with 10 millimeter, exactly 10 millimeter diameter. This is made by tungsten W. So both will be heated, but they will have to be heated from 25 degrees centigrade to certain temperature, and both will expand at different rates. So you can see that the steel will expand at 16 into 10 to the power minus 16 per degree centigrade, the thermal expansion, and the tungsten is 4.5. So it means that tungsten will also expand, but steel will also expand. But since steel will expand much faster, so it means that this hole will be enough bigger to fit in for this rod. But in that case, this rod will also become bigger. Okay, so in this case, then we need to equate the change in diameter for the both. So for example, for the case of steel, we can apply this equation. This equation is simply the same equation as the change in length divided by the original length. So just that we have used the length diameter terms for the length. So we can apply this equation for steel first and for tungsten first. For the steel first, the initial diameter will be 9.988, and the final diameter we need to know. For the tungsten, the initial diameter will be 10 millimeter, and the final diameter is the same as the DF. So the final diameter for both will be the same. So we apply these two equations. Okay. So this. So in this case, DF minus D naught is 9.988 divided by 9.988, okay, is equal to alpha L. Now we are talking about the steel. Steel is 16 into 10 to the power minus 16 into 10 to the power minus 6 into TF. So what temperature we need to heat it? So this we need to find. And T naught is 25 degrees centigrade initial temperature. So this is one equation. And the other equation is DF minus 10 divided by 10 is equal to, this is for tungsten, 4.5 into 10 to the power minus 6. And this will be again TF minus 25. So now we can, so the equations simplify into these equations. Now I can subtract the second equation from the first equation. So DF cancels with DF. This will be 0.012. This will be 114.808 into 10 to the power minus 6 TF, and this will be equal to minus 0.2. This will be 0.78287, and then also minus 6. So from here we can find the value of TF. TF will be equal to 0.012 plus 2870.2 into 10 to the power minus 6 divided by 114.808 10 to the power minus 6. So I need to calculate it. So it will be 129.5 degrees centigrade. So that means we have to heat up to 129.5 degrees centigrade. So within that temperature, the expansion in both metals become to such an extent that steel hole will increase from 9.98 millimeter to some diameter, and then this tungsten 10 millimeter will increase to some diameter. So what will be that diameter? Additionally, we can also find it. We can input the value of TF in any of these two equations, and then we can find the value of DF. So when you calculate it, the value will be 10.0047 millimeter. So the tungsten will increase from 10 to 10.0047, and the steel will increase from 9.988 to 10.0047, when the temperature of both will increase from 25 to 129.5 degrees centigrade.